All right, kids, this is all things RATEY. Okay, so we call this RATEY as in like rational equations. So we have a whole bunch of rational equations that we're going to be looking at. So RATEY basically stands for all of the parts of your rational equation, right? The 5 parts that we're going to do in order to make a sketch. So the answer to any rational equation type question is a graph. Okay, so we're looking at R stands for roots. The roots. So the roots are, of course, your x-intercepts. They're where the graph crosses the x-axis. They are your solutions. They're your zeros, right? R stands for roots. And how do we calculate roots? Well, you set whatever is in your numerator equal to 0. So if there's a number in your numerator, then we could have no x-intercepts, and that will be perfectly fine in your problem. Okay, so if there's no x in your numerator, if there's no equation in the numerator, and you just have a number, then there will be no x-intercepts for that problem. Okay, A, our next fellow, A, stands for vertical asymptotes. Okay, so the A is the asymptote part. A-S-A-M-P-T-O-T-E, vertical asymptotes. Right? These are the restrictions from your domain, the domain restrictions, the things that will make your denominator equal to 0. So we have to keep those out of your equation. That's where we have the vertical asymptotes. And you find that by setting your denominator equal to 0 and solving. Okay, and solve, right? Just like up here, we're going to have to solve this also. Solve that for x. This is going to be a point, right? An intercept is a point. So something comma 0, but your asymptote is a line. So we have a vertically dashed line through your graph. Okay, and then the T part. The T stands for table. Okay, and that's what's happening around your vertical asymptote. So maybe we have your vertical asymptote here, right? Maybe this is at positive 3. So you go a little bit to the left, like 2.9, and then you go 3.1. So we're trying to find out what's going on exactly to the left and exactly to the right of your vertical asymptote. So if we have a positive number, that means that the graph will go up to infinity, right? It will grow without bound on the left side of your asymptote. And if we have a negative, that means the graph will go down, right? It will shrink without bound down to negative infinity on that side of the asymptote. Okay, so it doesn't always be plus on the left and minus on the right. Whatever side is your plus or your minus is on, that means your graph will go up or your graph will go down on that side of your vertical asymptote. So E stands for end behaviors. So for very large values and for very small values of x, as x approaches positive and negative infinity, right? These are your horizontal asymptotes, or oblique, I guess, asymptotes, if the case may be. So that's where your E is going for, and we'll talk about the 3 different types of E's right now, whether it's bottom heavy, neutrally heavy, or top heavy. So if you have a bottom heavy function, that means that the power of your denominator is greater than the power of your numerator. Anything that is bottom heavy will always have a y equals 0 horizontal asymptote. So it could be x over x squared. It could be a number over x. Right? Anything that has a larger exponent or a larger power in the denominator is going to have be bottom heavy and have a y equals 0 horizontal asymptote. Okay, so what about neutrally heavy? That means the powers are the same in your numerator and your denominator. So x squared over x squared, right? Or maybe x over x. Okay, as long as the powers are the same, we have a neutrally heavy rational equation. And then if that's the case, we look at your coefficients. So this one would be y equals 3 because 3x squared over 1x squared reduces to just y equals 3, right? Or maybe we had like a 3 here and a 6. So y is 3 divided by 6, which is 1/2. Okay, so whenever we have a neutrally heavy, we are looking at y equals the coefficients. Okay, so we're looking at coefficients of your highest power, the coefficients of your variables for this one's horizontal asymptote. Okay, so it's not on your x-axis anymore, it is somewhere else, above or below, depending on whether that's positive or negative. And lastly, we have a top-heavy one, which means that the power in the numerator is greater than the power in the denominator. Okay, top-heavy. In this case, we have no horizontal asymptote. We're going to have to use long division in order to calculate or find the equation for the oblique asymptote. And for us, it's always going to be some type of a line, some type of a y equals mx plus b. Okay, it doesn't always have to be. It could be a quadratic or anything crazy. But for our class, we're just going to have a linear oblique asymptote. So the last question is, how do we distinguish? How can we tell if the graph is going to have a hole somewhere versus just having an oblique asymptote? Okay, so number one, it's oblique if it's going to be top-heavy. So we have to be looking at a top-heavy graph in order to decide whether there is a hole in our graph or an oblique asymptote. Okay, number two, you're going to calculate and find out that we have a root and an vertical asymptote at the same place. Okay, that's really going to tell us that there is a hole. If we have a root and an asymptote at the same place, that means there's going to be a hole in your graph rather than an oblique asymptote. Okay, a root and an asymptote at the same place. Okay, that will tell you that our graph is going to have a hole in it. Now, if it doesn't, if all your roots and all of your asymptotes are different, then you're going to have an oblique asymptote, and we'll use long division to figure that out. Okay, so it's strange when there's a root and an asymptote at the same place. Okay, so there's some conceptual questions. Now let's look at some math solving questions. So here are some problems. We want to find the roots of this rational function. Okay, and the roots come directly from the numerator. So we're going to set our numerator equal to 0, and we're going to solve this. Okay, and as it is a quadratic, we're going to solve this by factoring. Okay, what numbers multiply to give us negative 12, and at the same time add to give negative 4? And hopefully you know those as being negative 6 and positive 2. Okay, negative 6 times positive 2 is negative 12. Negative 6 plus 2 is negative 4. Okay, so those are your factorial numbers. And then we set each of our factors equal to 0, like we do when we solve all quadratics, and we get one x-intercept, or one root at x equals 6, and we get another root at x equals negative 2. Okay, so these are the points 6, 0, and the point negative 2, 0. Those are the x-intercepts. That's where your graph will cross the x-axis. So be able to recognize it both as an x value and as a point. X values and points. Okay, number 12 says, what are the vertical asymptotes? So we're going to take your denominator and set your denominator equal to 0. And we have another quadratic, so we're going to factor this, right? Factoring is a big part of algebra. What numbers multiply to give us negative 8 and add to give negative 2? Hopefully you know that's x minus 4 and x plus 2. So we're going to have vertical asymptotes at x equals 4, and we're going to have another vertical asymptote through x equals negative 2. Remember, these are vertical lines. and we would represent them on our graph with vertically dashed lines, okay, to represent the fact that we cannot cross over those vertical asymptotes. Okay, our next question says, in what direction will the graph go in relation to the negative vertical asymptote? So let's see what we're being asked about. So this is the negative vertical asymptote, right? -2 is a -1, and then we have +4. So we're looking at, right, basically our table. Will our graph go up on the left? Will your graph go up on the right? Right? Will it go down on the left? Will it go down? So that's what we're being asked for. Which of these four are going to be happening? So we're going to find that out by making our table. So here's your -2, right? That's the number in question. So we're going to be evaluating at -2.1 and at -1.9. So we're going to plug both of these numbers into your equation and see if they're positive or negative. Okay, so I'm going to use the factored form of the equation rather than the quadratic form. Okay, the factored form rather than the quadratic form. And let me tell you why. When I plug in at -2.1 into all of these things, I can pretty quickly tell whether I'm going to get a positive number or a negative number. Right? So if I were to think in my brain, okay, what is -2.1 plus 3? I would say that's a positive number, right? It's 0.9, positive 0.9. And then if I do -2.1 minus 4, well, that's definitely a negative number, times -2.1 plus 2, well, that's another negative number. So on the denominator, a negative times a negative is a positive, and a positive divided by a positive is a positive. So on the left side, my graph should be going up because I get a positive value. Okay, and similarly with the other side of -0.9. When I plug in at -1.9 into these and I evaluate them, -1.9 plus 3, well, that's another positive number. -1.9 minus 4, that's a negative number. And -1.9 plus 2 is a positive number. So I have a positive in my numerator and a negative in my denominator, because a negative times a positive is a negative. So my graph is going down on the right side of my asymptote, x equals positive -2, and my graph is going up on the left side of x equals -2. Okay, so this is using our table, right? T stands for table. We make a table to decide whether your graph goes up to infinity or down to -infinity. Okay, let's find 14, the end behavior. So end behavior means we're looking at heaviness. Okay, hopefully you notice we have an x squared in the numerator and an x squared in the denominator. So this is a neutrally heavy function. And when it's neutrally heavy, we look to our coefficients. So 4 divided by 2. Okay? Basically your answer is y equals 4 divided by 2. 4 divided by 2 is 2. So this graph would have a horizontal asymptote through +2. Right? I do a lot of other stuff, but we're only asked for the horizontal asymptote, the end behavior, horizontal asymptote of y equals 2, because it's neutrally heavy. Okay, 15, what is the x value for the hole in the graph of this function? So they're telling us that there's a hole, but where is the hole going to be? Well, let's find it. Let's solve the numerator, right, to figure out where your r is, your root. 3x plus 6 equals 0. 3x equals -6, so x equals -2. That's where the roots, one of the roots, actually the only root of your graph is going to be there, x equals -2. Now let's look at your asymptote. So we're going to set your denominator equal to 0, x squared minus 4 equals 0. We'll factor this to x minus 2 and x plus 2. So x equals +2 and negative 2 as your vertical asymptotes. So guess where your hole is going to be? You guessed it, it's going to be right here through negative 2. So x equals negative 2 is where you're going to find that hole. Okay, so your graph's going to do something, and then when it comes to the negative 2, we're going to have a point discontinuity, and it's going to continue on in there forever. Okay, now this next one says, what is the y value for that hole? Where exactly on your y-axis is this going to be? We know the x value is negative 2, but what is the y value? So what happens when we plug negative 2 into your equation? 3 times negative 2 plus 6 over negative 2 squared minus 4. Well, this is negative 6 plus 6 and 4 minus 4. 0 over 0. That's a predicament. That is undefined. So that's not a very good way to do, is just plug in straight away. Right? That does not tell us what the y value is. So we need to go back and look at your factors. Every time we have this, we're going to factor. So we can factor out a 3 from your numerator. And we can, of course, write this as x minus 2x plus 2. So we're really looking at the graph of 3 over x minus 2. Right, where we have a hole at the thing that got factored out. So what happens if I plug negative 2 in now? Plug negative 2 into this, and I no longer get a 0. I get a 3 over negative 4. Okay, now looking at the graph, does that look like the y value where I graphed it? Sure, I would believe that this has a y value of negative 3/4. So if you want to find out what the y value is, we factor your rational equation. We divide the things that can divide, in this case the x plus 2. And then you plug in that whole value, right, the whole at negative 2, into your new equation. And that will tell you where the y value of that hole is going to be. Okay, what is the equation of the oblique asymptote? So we're being told to find the oblique asymptote, so we're going to use long division. X plus 2 on the outside, x squared, plus 5x minus 4 on the inside. So this is where our brains need to think. What do I need to multiply x on the outside by in order to get x squared on the inside? And that would be just another x. So I write x up there on the top because that's where my answer comes from. And now I multiply. That gives me x squared plus 2x. Now I have to subtract, right? I'm going to subtract because that's what the algorithm says for long division, is you subtract the bottom from the top. So x squared minus x squared, well, that's 0. But then what is 5x minus 2x? 5x minus 2x is 3x. And we drop down that minus 4. Okay, where we turn to ourselves again and say, okay, x times what is 3x? And I have to multiply that by a positive 3. And as soon as we do that, we don't have to go any further because this is the equation for your oblique asymptote. Y equals x plus 3. So we're looking for an m, right? We want the slope. In this case, the slope is positive 1. And we want a y-intercept, in this case, positive 3. Okay, we don't have to finish off this long division at all. We're only looking for the b value from your second line of your long division. And then our last skill is writing an equation. So let's see what we have here. Your r and your a are your most important parts. So the roots, this looks like we have an x-intercept of positive 1. Okay, so if I have an x-intercept of positive 1, that means I have a factor. I have a factor of x minus 1. Okay, and that's going to be in the numerator of your rational equation. So let's go ahead and write that out here. X minus 1 is part of your numerator. Okay, let's go back here and look at your vertical asymptote. Okay, it looks like we have an asymptote at positive 2. So that's the a part, x equals positive 2. This gives us an equation of x minus 2, right? And that has to go into your denominator. So I have a denominator of x minus 2. So far, so good. Now let's see, what else do I have here? I'm noticing a horizontal asymptote of y equals positive 3. That means that I have a neutrally heavy equation, right? Neutrally heavy. So let's look at what we have over here. I have x on the top and x on the bottom. Sure enough, that currently is neutrally heavy. But I need to have a 3 in there somewhere. So I'm going to parenthesize this whole entire thing and put a 3. Okay, you don't want to just put a 3 in front of the x. Okay, you need to put it in parentheses, which would give me a final equation of 3x minus 3 divided by x minus 2. So let's see, the last thing would be the y-intercept. Negative 3 over negative 2, that's positive 1.5. So if I come back over here, does it look like my graph crosses at positive 1.5? I would say yes, my graph looks like it crosses at positive 1.5. So that means my equation that I wrote, 3x minus 3 over x minus 2, is a pretty darn good equation. Okay, so hopefully your conceptual understanding along with your algebra understanding will earn you a fantastic grade on your test coming up. Okay, goodbye.